Hello, welcome to ACE Manager. Bottom line focus. AS 27. Power. My last 3 or 4 podcasts have been referring to behavior of cause and activity level and how they impact the bottom line. While I do not presume that you will face identical situations in your working life to address similar problems, I presume that you will focus on the concept behind each story and its relevance, where you could come across similar analogy in your work situations. Power is an important item of cost. In this podcast, I like to share 2 specific instances where power generation on one side and power consumption on the other were significant in influencing the bottom line. Power generation. Power is an important item of cost in piston manufacturing. The plant was able to procure 50% of its power requirement from the concerned state electricity board quota, and the balance 50% was through self-generation. It had a generator set of 1000 kVA capacity and 3 small gensets of 250 kVA each. Those days, diesel used to cost 3 rupees 80 paisa per liter. Each of the small 250 kVA gensets were giving an yield of 1 unit of power per liter of diesel consumed. This meant effective cost per unit using the small gensets was rupees 3.80. The bigger genset of 1000 kVA capacity was new and was more efficient. Its yield was 3.8 units per liter against 1 unit per liter of the smaller sets. This made effective cost per unit of power generated as rupee 1 against 3 rupee 80 paisa of the small set. I realized that there is merit in replacing these 3 old gensets with another 1000 kVA set. Based on my recommendation, the old 3 generator sets of 250 kVA each were replaced by a new generator of 1000 kVA. It meant significant savings in power generation, and the payback period for the investment in the new set was less than 3 months. Power consumption. Aluminum alloy is kept in molten condition at high temperatures in the foundry. At most of the furnaces in the foundry, production was in 2 shifts basis of 8 hours, while some of the types required were produced during night shift as well. Night shift was restricted to few furnaces because it involved additional payment to the workman in the form of some night shift allowance. Keeping the molten metal at high temperatures for long hours in idle condition was actually costing more in terms of power consumption, melt loss, and consumption of indirect materials like fluxes. This cost was much higher compared to the extra night shift allowance which may have to be paid to the workman in case you ran 3 shifts. Based on our findings, number of furnaces in the foundry were reduced and night shift operation was introduced on a larger scale to achieve overall savings. Of course, the gains were very significant. I like to say a few words on different sources of power and how we could assess their relevance, relative impact on the bottom line. Usually, self-generated power would be more expensive than power purchased from the state electricity boards or when you buy wind energy. In all these cases, we should work out effective rate per unit based on total purchase cost as reflected in the power bill divided by the number of units available from that particular source. In the case of power purchased from the electricity boards, we need to note that broadly There are two types of charges. One is called demand charges, based on the highest quantum of power drawn at any given point of time in a period. The second is called consumption charge, representing the actual units consumed in a period. Effective rate per unit is worked out taking both charges into account. Needless to say, we need to learn to read the electricity invoices raised by the electricity boards to understand the effective cost per unit and accordingly make adjustments required in our type of power as well as consumption pattern. Trust, I've been able to give you some ideas on how to monitor power costs. Thank you for your attention.